Welcome to This Explainer. Today, we're decoding a really fascinating new government policy that strikes a delicate balance between India's rapidly growing electricity needs and vital forest conservation. We're going to be talking about that tricky intersection where massive infrastructure actually meets environmental protection. It really brings us to a huge practical question, right? How exactly do we build massive power lines through dense forests without, well, destroying the trees? Historically, expanding our power grids meant carving massive, destructive paths through pristine ecosystems. It was just seen as an unavoidable cost of development. But thanks to a brand new policy driven entirely by some super clever engineering, that narrative is completely changing.
Here's our roadmap for today. 1. Unpacking the RoW Amendment. 2. Technology driving the change. 3. Benefits to forest ecosystems. 4. Implementation and stakeholders. And 5. Summary and next steps. Let's jump right in.
Section 1. Unpacking the RoW Amendment.
So let's go straight to the source material that actually triggered this whole shift. What we have here is an official circular dated July 3, 2026, issued by the Ministry of Environment, Forest and Climate Change. Basically, this officially amends the old 1980 Forest Conservation Guidelines. By relying on the 2025 Central Electricity Authority regulations, it formalizes a completely new approach to how we build our power grids. Now, to really grasp the physical reality of this policy, we've got to understand what right-of-way, or ROW, actually means. Think of it as the physical path literally cut through a forest to make room for power infrastructure. Whenever you see those giant transmission lines cutting across a landscape, that cleared land directly beneath and around them, that's the ROW. It's a mandatory corridor. It has to be kept clear of tall trees and vegetation to prevent fires, keep things safe, and allow maintenance crews to get in there. Traditionally, to hold up those massive old towers, this corridor had to be incredibly wide, which unfortunately meant a ton of forest had to be cleared out.
Section 2. Technology driving the change.
So how are we shrinking these corridors? It's pretty amazing, actually. The engineering itself has completely evolved to solve this spatial problem. If you look at the older configurations, they required these huge tower footing areas and incredibly wide wingspans, and that directly resulted in those massive clear-cut corridors. But the new, modern configurations, they use sleek, improved pole and tower designs. They are highly optimized and much more compact, which means a significantly smaller footprint right there on the forest floor.
Section 3. Benefits to forest ecosystems.
Now, what does this sleeker engineering actually mean for the trees? Well, check out this number. By adopting these new technologies, the right-of-way land requirements in forest areas can be reduced by up to an impressive 20%. Just picture a huge power corridor slicing through a dense forest, and now imagine shaving a full fifth off the width of that clear-cut path. We're talking about a massive volume of land and biodiversity being saved here. Ultimately, this 20% reduction means we can deliver absolutely crucial power infrastructure while significantly minimizing tree felling. It protects the fragile ecosystems that thrive in those woods, and the government circular explicitly highlights this. It is a profound win-win scenario, you know? Upgrading our electrical standards now directly correlates to a lower ecological footprint. We're not just building better grids, we're actively preserving natural habitats just by requiring less space to do it.
Section 4. Implementation and stakeholders.
Of course, a policy is only as good as its execution, so the central government has laid out a really clear three-point directive to manage this transition from the old, bulky grid standards to the new, narrower corridors. First off, any new transmission lines built using the new configurations absolutely must follow the updated ROW requirements from the 2025 Central Electricity Authority regulations. Second, to make sure ongoing projects aren't just abruptly derailed, any construction using the older configurations will keep following the old guidelines for now. And third, the Ministry of Power steps in with a major role. They are tasked with issuing advisories to states and transmission agencies to actively push for these advanced technologies, with the ultimate goal of phasing out the old standards entirely.
Now, making all of this a reality requires some serious coordination across multiple stakeholders. When you look at the sign-offs on this circular, you've got the Ministry of Power, the Central Electricity Authority, and forest conservators from across all the states. It's this vast bureaucratic machinery, all syncing up to ensure that environmental preservation and energy development can actually work hand in hand.
Section 5. Summary and next steps.
Let's pull all these pieces together to see why this matters so much. This quote, pulled straight from the ministry's circular, really hits the nail on the head. It says, the advancements in technology have led to the adoption of improved tower and pole designs, thereby significantly minimizing tree felling and the overall impact on forest ecosystems. That right there is the ultimate takeaway. Human innovation in the power sector is now acting as a direct tool for forest conservation. By engineering smarter, tighter, and smaller infrastructure, we're literally leaving more of the natural world completely untouched.
And that leaves us with a really inspiring thought. If new pole designs and smaller wingspans can reduce our footprint in the forest by 20% today, will future technology eventually eliminate the environmental footprint of our infrastructure entirely? It's an absolutely fascinating question for the future of sustainable development. While we ponder that, please make sure to hit that like button, share this explainer with anyone passionate about the environment or engineering, and subscribe to our channel for more deep dives. Thanks so much for joining me today, and I'll see you in the next explainer.